Looking at the GitHub API response JSON, we can see that some of our model fields don't match. When Moshi tries to deserialize the response into these models, the property names need to match the JSON keys. We can either change the Kotlin properties to use snake case, or use the JSON annotation and explicitly specify the JSON key name. I prefer to use the JSON annotation, but either way will work. Open Repo API model. We need to update the last 5 properties here with the JSON annotation and the key name. We also need to make the description value nullable, since it's sometimes null in the GitHub API response. At the top of the class, add the JSON class annotation with generateAdapter true like we did before. This automatically generates the adapter for our object that Retrofit will use via the Moshi converter that will register in a minute. For user API model, the properties here already match, and so we just need the JSON class annotation. Next, we need to set up our module to provide dependencies needed for Retrofit. We started off just binding our mock GitHub API as the implementation for GitHub API, and now what we end up with is this. This module is the equivalent of writing a Java class with static functions, which leads Dagger to generate more optimized code rather than having a class object with instance methods. Using JVM static for each of the functions reduces the amount of generated code, but it's not strictly required as that extra code would get stripped out in optimized builds. Let's walk through each function. OK-HTTP client is used for the call factory for Retrofit. It's nice to have it separated out like this in its own function, or even in another Dagger module, since you may want to customize it with interceptors. Having all that contained to one function just makes it easier to follow. Moshi is used to convert JSON to Kotlin and Kotlin to JSON. We don't need any customizations here right now, but again, it's nice to have it separated out in case we do in the future. Next, we provide the Retrofit instance. This requires the 2 dependencies that we're providing above, and since those are now part of the Dagger graph, we can just declare them as function arguments, and Dagger will pass those along when we request an injected Retrofit instance. Here we'll register the Moshi converter factory, and that will use those generated adapters. And finally, we'll provide the GitHub API. Where before we were using our fake implementation, here we'll use Retrofit to create an instance. Now when our AppRepository injects GitHub API, it will get this instead of the fake one. Moving on to the GitHub API file, we will just delete the mock GitHub API class, and we'll annotate our function with the request path for the real GitHub API. This is really just a search for the top starred Kotlin repositories. In the build.gradle file for this module, we need to have the Dagger compiler run as an annotation processor, since now it has to generate providers that will be referenced in our application component. Now that the description of Repo API model is nullable, we need to make a couple small changes in our home ViewModel and home ViewModel test. We'll just fall back to an empty string if it's null, rather than making the repo item property nullable. And the last thing we have to do is declare the internet permission in our Android manifest. We could do this in either the GitHub API modules manifest or the apps manifest. With manifest merging, it doesn't really matter, but let's just do it in the app modules manifest. Now let's run the app. We have real data. Besides some very minor tweaks because of nullability, we really didn't have to change any code from our repository all the way up to the UI. Using Dagger, we swapped out the implementation of an interface, and the rest of the app just worked as expected. This is the ideal situation and one that Dagger makes much easier to set up.